Welcome to the ARCOS Proposers Day. The goal of this program is to automate the evaluation of software assurance evidence to enable certifiers to rapidly determine if the software is fit for use. We use the words risk. Certification is really a risk management activity. Whenever the DoD executes software, it's assuming some risk that the software is going to operate as expected, and have the right sort of non-functional qualities to it. And certification is the activity of trying to understand the residual risk in the software and accepting that risk. Now, I go through all that because we're not building tools to go through RMF faster. We're not going through tools to help us with NIST 800 controls. We're taking a step back and trying to understand, if we build software, how would we demonstrate to somebody we built the right software? And I'll start by saying that current certification practices, as we do them, are broken. We largely certify software the same as we did in the 80s, in that we generate a mountain of evidence. We give the evidence of the software to human evaluators who go through that evidence and try to convince themselves that the software is fit for use. And the current certification practices are often long, expensive, and an impediment to fielding new technology. To highlight this, I've spoken to a program in the Navy, and they've talked about a cost of doing nothing of $5 million. And what they mean is, if they take their certified software and they run it through the certification process the second time through has no findings, no modifications to the software, it still costs them $5 million and takes a year. So consequently, they believe the cost of changing one line of code is whatever it costs to change one line of code plus $5 million. And that also drives some other bad behaviors. And not only do they not want to certify too small of changes, they're also reticent of trying to certify big changes, because they're aware there may be findings, there may be costly rework, and the $5 million becomes something much bigger. So they have quite a delay from when they write a requirement to when they expect it to be fielded, something on the order of a decade, which clearly is an impediment to fielding new technology. And the way we certify things, and I put up the Common Criteria certificate for Green Hills because I was involved in that certification, and it took quite a long time. So we delivered the formal methods analysis artifacts to NIAP, who did the evaluation in April of 2006. So the evaluation was underway, at least by then. It may have begun earlier. You can see in the certificate that the certification was awarded in 2011. Now, this was a bit of an outlier for a number of reasons. This was the only operating system certified at this EAL6 Plus level. It's a rare case where the government certified a component and not an entire system, so they were taking extra care when they went through the certification evidence. But on the other hand, this operating system had been certified for FAA Level A use and was used in safety critical places already. So the judgment was the delta going from FAA Level A to Common Criteria EAL6 was not insurmountable, but still took upwards of 5 years to evaluate the additional evidence. I go through all this because, and I mentioned the human evaluators. The human evaluators are given a great deal of latitude in interpreting their requirements for certification. So one of the certifications for Green Hills on the separation kernel protection profile said that software modules should have good internal structure with no undue complexity, with minimal exceptions. That was literally a requirement for certification of this operating system. And what does that mean? Good internal structure, how do you judge that? No undue complexity, how do you judge that? And this last phrase, last clause, with minimal exceptions, what does that mean? And we did the pragmatic thing. We went to the NIAP evaluators and said, what does this mean? And they kind of spelled out what it means. But had we a different set of evaluators, we most likely would have got another answer. So certifications are expensive, they take a long time, they're human-driven and error-prone, and they're inconsistent depending upon which set of human evaluators you're working with. And I've talked a lot about assurance evidence, and what do I mean? Typically, we deal with 4 different domains of evidence: test data, simulation and emulation data. And I mentioned those first because I've talked to evaluators for software that go into weapon systems, and I've asked them, what do you do when you evaluate software? And they said, stimulate, emulate, simulate. So test, simulation, and emulation are the 3 key areas, the 3 sorts of evidence they use in evaluating that sort of software. Analytic evidence seems self-evident. We'd like to see more formal analysis done on software, but there's also other structured analysis such as a safety case analysis or timing analysis or what have you. And last is software quality assurance evidence. So this is things like traceability of requirements, and often it's not evidence of the quality of the software being judged, but evidence of the process used to build that software. Did we use a mature, robust software development process, and did we adhere to it religiously over the development of the software? Those are the types of things used to accredit software. What we'd like to do instead, and I'll start on the right and work my way back to the left, is we'd like to generate assurance case arguments that have been validated and have some kind of indication of what sort of confidence we should have in these arguments. And to do that, we want to have all of the evidence available in a binary form that's amenable to analysis. So this looks a lot like a data analytics problem. We have this large pool of evidence. We want to mine it for assurance case arguments and then validate those arguments for a sound logical structure, and what is the confidence we have in the argument based upon the evidence it's built upon. And since this looks like a data analytics problem, we want to have the highest quality pool of evidence that we can possibly get. And it's different than a lot of data analytics problems where in many problems you're analyzing data. The data is what it is, and you just have to live with it. In this case, we're purposely generating the evidence to go into this pool. How can we do a better job, both for legacy and for existing software? Quite a few people have talked to me about the shape of this program over the last year as I formulated it. I'll just say that this is the final numbering of the TAs. People have talked to me or have talked to people who've talked to me may have different numbers written in their notebooks, but these are the final ones. So TA1 will be the generation of better evidence. And how do we judge better? Better means that we get higher quality assurance case arguments out of it with higher confidence. TA2 will be the curation of evidence. So being able to take all these different sorts of evidence, put them in a common representation, and groom them so that they're amenable for analysis. TA3 will be how do we mine this body of evidence, generate assurance case arguments, and then back those arguments with evidence to show that they're valid arguments. And TA4 is quantitative assessment, and there's sort of 2 goals there. One is to provide test beds, provide challenge problems to the performers, and the other is to run periodic assessments on how well the program's doing. And there'll be more in that in upcoming slides. So TA1, generating evidence for new software. I'm envisioning an assurance-driven development technology. So we're engineering assurance cases ahead of the software and allowing the shape of the assurance case to influence and inform the design and implementation and verification of the software So the eventual evidence supports that argument. TA1, evidence generation for legacy software. I'm looking for automated ways of taking existing software, either COTS or pre-existing software, and the existing evidence that comes with that software, analyzing that evidence and finding where maybe it's wanting, and coming up with automated ways, automated test case generation, automated analysis to bolster the existing evidence in the light of the certification criteria we're trying to address. Evidence curation, we want to develop a representation of evidence from the different domains that allows the evidence to be groomed and makes it amenable for analysis, allows the evidence to be correlated with the implementation, and also to attest to the provenance of the evidence. So if we deliver an assurance case argument to an accreditor with evidence that support it, they may want to know from whence did this evidence come. Who generated this test? When was it generated? One thing I've glossed over is we also want to do this in a way that is compositional. So can we evaluate a component in isolation and then later use the evaluation of that component in the evaluation of a higher level system? If we're doing that, we'll need to be able to track the provenance of the evidence over long periods of time. TA3 is assurance generation, and this also has two parts. The first part is to iteratively construct an assurance case argument and then mine the body of evidence to back up that argument, and perhaps recurse over a tree structure to flesh out what the argument looks like. Then the second piece of it is a tool that is demonstrably correct, or we have a higher amount of confidence in, that will validate the assurance argument and provide some sort of measure or narrative on why we should trust this argument. Or maybe it's a narrative on where the argument is weak, allowing the evaluators to dig in at that point. We're looking for the evaluation tool, the assurance case validation tool, to be automated, but also we'd want it to be used in a way that is semi-automated, so an evaluator could use it to look at these assurance case arguments and to work quickly through it to understand how much confidence we should have in that argument. Quantitative assessment, I've mentioned we're looking for a series of test beds. So over the course of the program, the different phases, building up the complexity of the test bed for the performers to be judged against, and also running the quantitative assessments. And doing the quantitative assessments, working with a team of government SMEs. So we'll have a team of government certification experts who will look at the newly generated evidence and the generated assurance case arguments and give them either a thumbs up or a thumbs down. Hopefully the thumbs down will come with qualitative feedback on how they could be doing better. But the quantitative assessment people will run the tools over the test bed, collect all the data, and perhaps sample the newly generated evidence and the assurance case arguments so we don't overwhelm the panel of government experts. They'll be finite, and honestly, these people have day jobs. They may be busy. We'll be lucky to get their time when we have it. I'm trying to over-provision the panel as much as possible, but part of the quantitative assessment TA job is to come up with a way of sampling all of the output that provides confidence that all of the output is valid. I've talked about the government assessment team. Their job not only to work through the quantitative assessments and look at the generated articles and provide a thumbs up, thumbs down, and then qualitative feedback, but we also want them to be a sounding board for the performers to let them know, yes, this sort of thing I would sign off on a certification. No, this doesn't hold water. You're going to have to do better, and hopefully better, more detailed feedback than that. I've talked to certification people from across the federal government, not just the DoD. NASA is very interested in being involved. NSA wants to be involved, Nuclear Regulatory Commission, NIST, and then people from across the DoD. So we're going to have a very wide swath of government certification people judging these artifacts. So the goals and metrics for the technical areas are these. Haven't mentioned the phases and the durations yet. So 3 phases. The first phase, 18 months, will focus on a single software module, both trying to see if we can evaluate a module in isolation and also giving us a starting point. The second phase will also be 18 months, looking at some set of software modules so we can start to see if we can do composition of evaluations and have a bigger overall system to try to provide assurance for. And the last phase, a realistic military system. I'm very interested in something that has a rich set of certification criteria. So both enterprise security sort of criteria and maybe DoD system safety, or maybe DoD system safety and DoD airworthiness, or any combination of those. But we're looking for certification criteria from across a number of domains to see where this approach will work and maybe where it won't work. In the first phase, we'll limit the sorts of evidence that we'll try to work with to test simulation and emulation. Again, this is what a lot of weapon system people work, so we'll at least be doing the same level of evidence that a lot of weapon systems are judged by. In the second phase, we'll open it up to all sorts of evidence, and the third phase will largely be scaling. Assurance generation, so the TA3 generation of assurance will take a leisurely 4 weeks to generate that in the first phase, and by the third phase, we hope to get it done in less than a week. Now, the TA1 and TA3 evaluations where we have the government evaluators involved. In the first phase, we're looking for half the evaluators for any particular piece of evidence or assurance to give a thumbs up. By the end of the second phase, we're looking for 2/3. At the end of the program, almost all. Now, given the breadth of the evaluators, I'm not trying to say we'll get a consensus of everybody, so I'm giving myself a little bit of wiggle room. But by the end of the third phase, we're going to want almost all of the evaluators to agree with their work outputs. TA2, as far as curation of evidence, I'm imagining the evidence will be stored in some sort of graph structure. We're expecting that graph structure in the first phase to have more than 100,000 nodes, more than 1 million nodes in the second phase, and at least 10 million nodes in the third phase, if not 10 times that. The schedule, as I said, 3 phases, 18 months, 12 months. In the first phase, we'll have 2 assessments. In the second phase, we'll have 2 assessments. The first assessment in each phase will be sort of a vector check, dry run. We want to get early feedback to the performers on their approaches and the sort of work products that they're producing so that they have time to do course correction. The end of phase assessment will be for score and reported up to leadership and across the DoD probably. Then in the third phase, only 12 months, we'll have a single assessment at the end, kind of a graduation ceremony. We've limited it to addressing one technical area per proposal. In TAs 1 and 3, we're anticipating multiple awards. And each TA 1 and 3 has sort of 2 thrusts or 2 tracks. You can respond to only one portion of each of those technical areas, but we're encouraging people to address the entire TA. And if you're addressing the TA, it's a good idea if your technology bridges the thrust. I will point out that if you're doing multiple thrusts in TA1 or TA3, I think you get 3 extra pages in your proposal, so there's that motivation. TAs 2 and 4, there'll be a single award. We want to make sure the TA4 performer has no conflicts of interest with the other performers since they're be involved in the judging of the technologies. We're encouraging teaming. I mentioned a couple times that we have the counter set up in the lobby in the reception area for people to share business cards. We have a couple sessions today where we'll allow people to get up for a couple minutes to explain what they bring to the table and what they're looking for in teammates. Then at the end of the day, we'll leave this room open until 3:30 so people can network and start making those connections. Today's the Proposers' Day. Abstracts are due in 10 days. We'll try to turn around feedback on abstracts as quickly as possible. I'll point out the 24th is the day before Memorial Day holiday. I don't know if the infrastructure at DARPA will get me the abstracts before the holiday, if I won't see them until Tuesday, but we'll try to turn those around as quickly as possible and get people feedback. Proposals are due and the BAA closes on July 9th. The due dates are always noon Eastern time. That's all I had. I think John's up next. Dr. John Seal.
So Ray asked me to get up and talk about some of the challenges that we see from the certification of software, weapon systems, combat systems, etc. Why am I the guy to talk to you about this? Well, first reason, I've been deploying weapon systems into the DoD for the Army, the Navy, the Marine Corps, and SOCOM for most of the last 20 years. I'm one of the folks who has successfully taken a design to the combat fields in Afghanistan, in Iraq, etc. in less than 18 months. So I've learned a thing or two about what it takes to do this. My last job, I was also the Deputy Chief Engineer and Tech Warrant Holder for Nuclear Weapons Surety for the Department of the Navy. It's a pretty major job, as you can imagine. What goes with that is a need for substantial technical rigor as we certify systems into that kind of an environment. So I'm going to talk a little bit today about what we've seen over that 20 years, some of the challenges, because I think that addresses precisely why this is such an important effort, and perhaps some thoughts on what we see missing right now in the ecosystem as we look at these things. First and foremost, when we certify a system, the desire is that we're finding a system that is safe, sustainable, and reliable. That is to say, it works within its performance envelope and does not introduce additional risks to the crew, to the users, to civilians that may be in the area. Has to be sustainable. Has to have an architecture that fundamentally we can update. Unlike the commercial world where products typically have a lifespan of about 18 to 24 months, I have ships that will be in the fleet for 50 years, so 17 commercial life cycles. That means that we've got to have systems that we can actually understand, maintain for the long haul. Over that 50-year life cycle, I'm likely to see the ship and be able to touch it significantly twice during its lifespan. So the computational stack that I have when that ship deploys is the stack that I have for about 15 years. That has some unique and interesting challenges, as you can imagine. And it has to be reliable. What does that mean? Well, it has to do the function that we intended for it to do in the first place. We often get that from the conventional test suites, okay? It works, it does the function as it's intended, but it also has to not crash on a regular basis. Some of you probably are aware of weapon systems and reports, and GAO puts these out every year where we see startling numbers. 2,000 problems in weapon system X, 1,500 problems in weapon system Y. Why do we see that? F-35 and DD-1000 are legacy platforms for us. So we're looking at systems of 35 plus million lines of code, high degrees of complexity that have truly become legacy. We're on tech refresh 2 and 3 of some of these systems that are not fully deployed at this time. And yet I'm up here telling you they're legacy. 35 million lines of code. The complexity of this is getting beyond our ability to certify, our ability to fully understand and to take care of those things. And of course, my system just turned itself off because power saving is my friend. So, my certification people would like me to say, we're looking for ways to speed up and assure the testing processes. Certification probably doesn't take that long if we have all of the evidence, but we have to have the right evidence. It has to be quantifiable, ideally, repeatable. That is to say, when I run the process a second time, I really want to get the same results, which is not always the case. As Ray indicated, we have humans in the loop. Those humans have differing opinions. So where we can get to quantifiable data, that is highly, highly important. Certification of a weapon system can take 12 to 18 months after we have the weapon system delivered. So it may take upwards of a year and a half when we have the system in our hands. If we're getting the right evidence, we'll be able to deploy that more quickly. That in turn puts fewer American service members at risk in the combat zones and returns them home as early as we can. This is a very real problem. When Ray talked about $5 million to change a line of code, I own at least one of those systems right now. So this is a very real problem. $5 million may actually be a low number in some cases. It is a very expensive and very rigid process to go through. It's also difficult to assess risk in a piecemeal fashion. A lot of the software tools that we have today can give me information on that particular module, perhaps a little bit of information about its interdependencies. We need to be able to look at an entire complex software ecosystem when we do this. So not tens of thousands of lines of code, but millions of lines of code, many of which may be operating in parallel. For example, I may have sensing functions going on around a platform or a ship, operating in tandem with functions looking at evaluating whether that is an inbound threat or to fuse the data that we're getting from all those sensors to provide a better picture. We may be conducting ground, air, and sea operations all at the same time on a single platform, so parallelism becomes important within that. And these are some challenges that we don't see being addressed right now in a way that gets us that evidence that we can curate carefully, go through and have a high degree in confidence in. So beyond the lines of code itself, there's a few other challenges that I'd like to hit. One is the tools and the libraries. It's really easy to look at the code that you wrote in every case. We get good reports on that. We don't always get good reporting on the tools and the libraries themselves. Can we move to a point where we have some type of formal verification of the tools, the compilers, the libraries that you're using, so that we have a sense of the assurance of those as well? You might scratch your head and go, God, that seems like it would be really easy. I've got to tell you, we've got systems right now that have on order of the smallest Navy platform is 8,800 subsystems. I'll say that again, about 8,800 subsystems, all of which are very software dependent and highly complex. Do you think we actually have complete and perfect knowledge of every single library that has ever been touched in those systems? And oh yeah, I'll add the configuration management piece to that because we'd really like to know which version of that library we have as well. I see a few of you chuckling. Some of you are aware of this particular set of problems. This becomes very real, particularly as we look at the world of automated test. We ran some great automated tests, Great. Which version of the libraries did you have? Which version of the software do you have? And do we have the proper evidentiary chain that allows us to maintain the confidence in that analysis and the set of testing that goes with that? Agile and DevOps are coming to DoD. I hope that's not news to anyone. If you're not already doing Agile, at least you will be in the next few years. As we move into this environment, we have this great opportunity. Rapid software changes, maybe as fast as Netflix. One of my bosses recently challenged me to go as fast as Netflix. Netflix rolls out a couple of hundred software changes a day. If you receive one of their bad patches, you're upset because your movie doesn't run. Worse, your kids may be upset. Has anyone gotten a bad iPhone, Microsoft, Netflix patch and your kids are in the back of the car at hour 6 of whatever lengthy journey you're on? It becomes very important in your life. In my case, I don't have that problem, but what I have is a system that may be in the Straits of Hormuz with 13 fast approaching vessels coming at it that I need to identify. Are those just fishermen? Or do I have a hostile inbound threat? We do not have the ability to reboot these systems in the real world. Somewhere between 500 and 7,000 young people are depending on that system, working each time, every time, and our confidence in that system. Architecture matters in all of this. I would encourage everyone as they think through this to realize that the software is not divorced from the hardware and is not divorced overall from the mathematical structure, the graph theory behind that software. Complexity matters. The more complex an individual software mechanism is, whether that's a component, whether you think of it in terms of objects, whatever, that complexity carries into the system that we're attempting to certify. The more interconnects that it has in any given module, the more testing we have to do. It's an exponential problem if you stop and think about it. Each module is interconnected. There's some really smart graph theory out there that some of you can probably bring to bear to help us to understand that. There's also the issue of things that are highly fungible in the real world. We have data that won't change when we put the ship out. Physics is probably not going to change over the life cycle of the ship. Granted, we have a prize every year called the Nobel for doing exactly that and changing those rules. But in the absence of that, the physics of a lot of these systems won't change. What will change is data like electronic warfare profiles, sensor profiles on how the sensor may be being used, perhaps an ammunition type, perhaps a tactic for a specific environment. If people think back, counter-IED was a major topic about 5 years ago. As you can imagine, we were losing a lot of people. Managing the libraries for those systems was a significant effort. Certifying them was a significant effort. Highly fungible data, those tactics changed. Hey, they're blocking this kind of phone. We need to switch to a different one. If I have to recertify each of these things through a 12 to 18 month process, we lose. It's just that simple, and it's very expensive. We can't do that. So how do we start to look at that data differently? How do we architect the software that we're getting so that those things that will change quite regularly don't touch systems that are heavily certified, such as a ballistic firing kernel that may be certified, may require NATO certification in order to guarantee that we're putting rounds on target in the correct places. How do I not touch a certified safety system for an autonomous vehicle to keep it from running into things, whether those are pedestrians in an environment, another vehicle, or controlled flight into terrain for my air brethren that are out there, because I see a few of you. CFIT is a really bad idea. So how do we certify these things so that those changes don't impact the primary safety features of those systems and create new risk in those environments? I'll also add scaling. We can do these for fairly uncomplex systems. 8,800 software-driven systems on a small platform. It's fairly easy for us to test trivial systems. A few 100,000 lines, 30, 40,000 libraries. When we get into much more complex systems, we are looking for solutions from a certification perspective that can scale to those extremely complex systems. I don't have just a radar in many cases that I'm certifying. I'm certifying a radar, a fusion engine, a track engine, probably a search radar along with it, perhaps several different weapon pairings that may be a part of that, as well as the timing elements and algorithms that may go with that. So some of the kinds of evidence that may also be of value to us, if we go back to about 2000, before the big internet explosion, we talked a lot about the idea of hardware technical data packages and software data packages. State transition diagrams are excellent. Event timing diagrams help everyone out. We don't always see these when they come out, and those types of objective qualifying evidence are extremely valuable from a certification perspective. So the ability to generate those from code that we may or may not have all of the source to becomes a very valuable thing to have and to make available to us. Along with the complexity of those things. We talked earlier about graph theory. Big O and the complexity of algorithms. Can we reduce the complexity of these tasks in a way that enables us to run these certification activities more quickly? Finally, I want to talk a little bit about test coverage. Lots of people like to talk about test coverage. We got automatic test coverage. We've got 80% of your software requirements. That is awesome, except you've really got the same module 10 times that you're counting in there because we did a lot of happy path in there. We need to think about how we expand test coverage and what that means. It's not just how much of the system was covered, but how well was it covered. We understand happy path testing. Got it. Goes with test-driven design, behavioral-driven design. Would like to understand what negative testing you've done that goes with that. How to improve the negative testing on that. If I'm operating in the Northern Hemisphere in America and I suddenly see a blip appear in Australia, there's probably a piece of errant data somewhere in the system. Would like to understand where we've seen that, what tests have been done to prevent that so that we don't see that in the real world, along with these parallel operations, configurations, and environments. I'm just about at time, so I will close with the idea of accessibility. Not everyone is a software engineer. Many people actually don't like software. Interestingly enough, I don't understand this, but they're out there. The data that we get from these systems has to be accessible to someone who may have a mechanical engineering degree that's 30 years old, may have been a major program manager for the last 10 to 15 years and be a lot more concerned with budgets than what the software bit is actually doing, or the fact that you've done a really cool XOR division to divide by half. We need these in a language that we can communicate to the folks who are less technical, because in many cases when we're making decisions about architectures, about whether a system is ready to certify, et cetera, there's a very human component to this, which is, can we take those who are not in the technical professions, convey that information to them along with a risk evaluation. So again, safe, suitable, reliable, and I'll remind everybody that Murphy was an optimist. Thank you.
So the ARCOS program is about automating the processing, let's say, and the generation of evidence for the assurance of systems. And in the past months, we have been working with Ray on this seedling project precisely on this topic. So the goal of our project has been, on the one hand, to extract as much information or evidence as possible from the system, in this case from artifacts of the system, anything that can be relevant to know more about the assurance, and to expose this information to engineers, to developers, and a way to understand better how the risk of the system is distributed across the system itself. Okay. As I said, we have the goal of, on the one hand, quantifying the risk. So we want to have some kind of measure about the risk, and also to expose this risk in order to understand how this affects the assurance of the system. We are thinking about safety critical software systems. And we also have a component-based approach because, as Ray mentioned, it is important to think about the systems in terms of components so that what we can learn about a specific assurance of a component can be used later on to reason about the assurance of the system. And also to leverage as much information as possible potentially from any kind of source which can be useful to reason about assurance. Okay, so one of the main motivations we have in our project, and this is in sync with previous programs such as HACMS and now CASE, is to close this gap that is well known between traditional software engineering, where we have a mixture of systematic but also informal processes, with formal methods, which are very conclusive but cannot be applied to the complete system. The approach we're taking here comes from a different angle, in the sense that we like to take a view of the whole system as such and start analyzing the data to be able to pinpoint places in the system or in the code where risks can occur or are emerging and are then sources for potential problems with the assurance. This is not a verification, in the sense that we cannot really say, based on our approach, there is a particular problem for sure in, say, this component. But we are gathering, since we're gathering information from multiple sources, to indicate that this particular component has a higher chance of maybe having a problem, and then validation and verification efforts, further efforts to assure the software piece, or say a component, should be done on that piece based on the assessment that our system provides. Okay, so in the case here of the picture, I'm working with an industrial robot in our facility in Princeton, New Jersey. Of course, as an example, I would want to be sure that the robot will not hit me at any point in time when I'm working on this. So the question is how to know this. And so we talked about this problem, and actually it's quite complex, and we'll see in a slide later that since the way the system is built and the many different components, both software and hardware, that are relevant for, say, a safety function that avoids human accidents, requires a holistic approach to look at the whole picture in order to understand what are the real chances that this can happen. Okay. Our approach combines, on the one hand, reasoning with uncertainty. So it's a principal mathematical approach. And on the other hand, static analysis. Here, static meant in the broader sense of processes that can gain information from all the software artifacts without actually having the software deployed yet. So we're looking at all the production of the software development process in order to have quantified and supported metrics for the assurance and the risk. So the aim of the general aim we have, and we can say this is the dream behind this seedling project, is to eventually come to a kind of continuous closed loop for a risk assessment. So if we have the software development process starting from requirements over to design, implementation, and then deployment, and several stages, at all stages in the software lifecycle, we have artifacts that are being produced of various sources, and that they all potentially have information which could be relevant for thinking about or assessing the assurance of the system. So the goal here is to have a principled approach to gather information from any of these levels in multiple ways, of course, because this is very heterogeneous, bring it together in a common knowledge representation, in this case, our heterogeneous graph of graphs, which combines knowledge graphs of different aspects together into a larger graph, and then use this as a basis for the analysis. So this analysis will throw out different visualizations about the assurance of the system, and by showing this or exposing this to engineers or decision makers, say strategists, then the development life cycle or the development process itself can be affected, from like a simple affection, fixing some bugs, all the way to maybe even changing the process in some way, and this closes the cycle. So as we get new information, as the software is being developed, then this will update the information in the graph, of course, and this will trigger the visualization and changing, and this is how the whole loop will work. So in the project, we have been developing a prototype of this approach, here exemplified in the case of a mobile robot application, assuming we have, for instance, a entire system, say based on a C++ code mostly, we can run different kinds of analysis and also extracting information from the different toolings that are used when developing the software. So we can consider formal verification as part of it, but also say static analysis tools, debugging, running simulations, like say running memory checks, even looking at, it's not here in the slide, but we're actually looking at a bug tracking system and extracting information from the bug tracking system in order to understand better how the software has been developed and where are potential risks. All this information is then consolidated into our graph of graphs. It's one of the algorithms we have for consolidating data. And then this is the basis, as I said, for the analysis. So for instance, we can, by risk calculation and risk propagation, which will then determine how risk in one particular element of the system can affect or either increase or decrease the risk at another element in the system, and then run this whole analysis for the entire graph of graphs. The visualization is then provided to the user in the forms of an assurance heat map. I'll show that in a slide later, that can really expose visually to the user where do the different, let's say, where the hotspots of assurance or risk throughout the system. Okay. Another point worth mentioning, of course, the traceability to root cause. The representation of information also provides a way to trace back any, say, found a particularly high risk that was found in the system back to the original sources of information that were used in order to calculate this, in order to find potential root causes for the risk that has been found. Okay. So looking at one of the use cases that we are analyzing in our project, we have an industrial robot application, as I mentioned, together with the question of human safety. So if we put robots and humans together in an environment, what is the risk that there could be an accident with respect to the human and the robot? So we have an in-house modeling and simulation environment at Siemens where we can actually develop the logic that drives the robots in the simulation itself. So as we generate or create the logic, you can try it out in the simulation. And we've been using this in order to build the use case. Now, the interesting thing here about the system is that in order to reason about the safety, the human safety, we need to look at several levels of logic at the same time. So on the one hand, you have the actual application behavior for the robot, which is specified in the visual graphical data flow language that specifies the logic before it actually gets deployed to the controller already in the simulation. The simulation framework itself is a piece of software running in an engineering station where basically the semantics of the different components are implemented as well, and that needs to be analyzed in order to understand what are the, let's say, the different situations that could occur for a particular application. And furthermore, once you deploy that, the system to an actual controller, we're looking at a completely different system there. We have a real-time operating system with a runtime environment, which is equivalent in behavior to the simulation environment, but it is a different system. So of course, a lot of the analysis results that you can do on the simulation can apply to the system, but being a different environment, you need to really reevaluate many of the dependencies there, because a lot of the developments the implementations are separate, right? So thinking about how to acquire data for the system, we have multiple data providers that have been implemented. And for instance, we have parsers for code, for instance, of course, C++, C# in this case. The simulation model itself with this graphical logical language needs to be analyzed as well. And in the case of an architecture model that has been modeled in a modeling tool, say an UML diagram, that is ingested at the same time to the system, so that we have also knowledge about the actual design of the system, not only at the code level, but actually at the component level. Furthermore, static code analysis, model analysis tools can be run on the system to have information about the actual, let's say, possible issues or bugs or uncaught problems or exceptions that can be found in the system that can also be put into the graphs. And finally, the output of simulation runs. So we see this not as a runtime topic, but actually as an engineering topic because it is part of the design. This can give further insight into the system, and this can also be put into the graph of graph. So the result of this analysis, as I said, is our composed graph. Here are some pictures where you can see that as we add more and more data coming from new data providers, of course, the complexity of the graph increases. And what at first is still human readable with the architecture, very quickly becomes not really manageable anymore with the naked eye. When you start adding, for instance, source files, and then source files plus the results of static analysis, or here below, we add actual structures of the code by using the parser. We do not stop at the level of the source file, but we go at the level of the individual code elements. Or interestingly here below, where we add information about the code management system. So for instance, in a bug tracking system, correlate let's say the functions in the program with bugs that have been reported in the system and comments that have been done to that, and putting it all together into a comprehensive model that already has a lot of information from very different sources that can be analyzed. Okay, this view is, say, a flat view or as-is view of the data, which is showing the reality. Of course, since we have the architecture, we could use the architecture view to collapse this view in order to lower the complexity of the graph for the purpose of understanding the structure. And so this is why it's very important to have information about the architecture of the system, which is basically the guiding structure of the knowledge representation we have. Okay, so as I said, looking at the graph is interesting, but probably not practical on a day-to-day basis when software developers are going to be looking at this. So we have been developing our interactive web application, which has the assurance heat map that I mentioned earlier, where we have a graphical visualization of the risk at the various system elements for the different aspects that we are considering. And through a simple color coding, we can very quickly point out where has risk been concentrated. And the idea here is to use that in order to do a deep dive to understand, maybe to indicate software developers you should look into this component, and then provide further, let's say, evaluation results, testing through the tracing back to the root causes, trying to understand why this is the case. So this is the idea of the tool is to provide an interactive means to visualize the assessment of risk, and to use that to understand the actual risk in the system and to complement other approaches. Okay, so in general, I would say that the most important idea behind our project is the message that data-driven approaches can complement existing technologies very well. If you think about what we have with testing and validation, we can use it to analyze or to consider reproducible errors of the system, which is a precondition for being able to have a test. It needs to be reproducible, and the whole process is commonly manual and inherently incomplete, as we know. Although there are current techniques to automate test case generation and to assess coverage, it is still inherently a manual process, right? And it's a trial and error process. But it has, on the good side, it can be applied to the whole system or to components, so it's very scalable. On the other hand, formal methods, as we know, are exhaustive, they're conclusive, but the fact that we need to provide precise models of the system make it difficult or impossible to apply to complete systems, and as we saw in the previous talk, real systems with the complexity they have, they're not really something that can be completely tackled by formal methods. So we see our approach here as a way to bring these two together and to have a general, first, let's say, broad assessment of risk, where we are tapping into sources of information that cannot be or are not really used either by testing or validation or by formal methods. They're completely out of scope of these tools, but they can gain insight. They can give us insight as to where we could find potential focuses of risk in the system. We can have a quantitative assessment of a risk and assurance, so we can also say, let's say, rank components by, say, the level of risk that has been come out of the system and concentrate on those with the highest risk. And it also allows us to have a dynamic visual monitor of a calculated assurance. So we believe that technology like this can actually be integrated into software development cycles as a way to assess the risk at a general system level and to be able to guide the verification and validation efforts. Finally, as I pointed out, the approach is scalable from single components all the way to the complete system. And you have different levels of granularity, but it's basically a matter of looking at the whole system and considering that in any case, the assessment of the risk that you do at a particular point in the system can be used to assess the risk and how it is flowing into other parts of the system. So this supports naturally a component-based approach, and that can be done at multiple levels as well. Okay. So I think this summarizes our current results for the seedling project. Thank you.
So next up, we have Mark Jones from Contracts Management providing the best part of the day, explaining how to work with DARPA. Mark?
Thanks, Ray. All right, good morning, everybody. So as Ray just said, I'm Mark Jones from the Contract Management Office. And next 30 minutes or so, we're going to have the most exciting presentation of the day. For those of you who have heard it before, you know I am lying. So let's get started. Okay, the BAA is out there. Usually these slides, unfortunately, were written as if it wasn't out there, just because I just couldn't get them put together yesterday in time. The BAA is out there, so anything I say, if it is wrong, go by what is in the BAA. That takes precedence over anything either I or anybody else says here. Whatever's written is what you're going to follow. It's out on FedBizOps. If we, for some reason, decide to do any changes, make any amendments, we'll post those also to FedBizOps, and you want to take and look at whatever is the most latest and greatest version out there. All right, so the proposal preparation information. I'm not going to go over a lot of the specifics of the program because I didn't put it in my slides, but this will be a sort of a generic talk. If you have questions, go read the BAA. Everything is in the BAA that you need to know, and it's all laid out there how we want you to submit it. So just follow what's in the BAA when you're putting your proposals together. So first off, your proposal submission is going to consist of 2 volumes plus 2 other attachments. So the first volume is your technical volume, and part of the technical volume is your Appendix A. The tech volume does have a page limitation. It's 40 pages. Unless you're submitting multiple solutions for Technicals 1 or Technical Area 3, in which case we add additional pages to that because you are going into a little bit more than just the one approach solution, etc. So make sure you fit your solution within that page limitation, whatever it is, 40 or I think it's 44. If you exceed that page limitation, we're just going to stop reading at that point. So if your point hasn't gotten across to us by the page cutoff, then you may be seen as a weakness and your proposal may not be selected because you may not have gotten your great solution to us in time. There's an Appendix A that we want you to fill out. That doesn't count towards your page limit. Make sure you do fill out that information and provide it to us. A lot of it is kind of easy to answer questions. We want to make sure that you have seen it and you've gotten that information to us so we don't have to go back and ask for clarifications. Some of it may not apply. Animal use is always the example I use. Most of I2O programs don't involve animals, but we want to make sure you know that or you have told us that so we don't have to consider that when we're doing the evaluation. So just put not applicable, but do address it in your proposal one way or the other. There may be an Appendix B That's not mandatory. I can't remember if that was in the BAA or not. So if it is and you want to fill it out and submit it, you can. If you don't, that's fine also. But make sure you do Appendix A. That is required. Then Volume 2 is your cost volume. There's no page limit to that. So go at it. Just make sure that when you do submit a Volume 2, which is your costs, try to include with it a working spreadsheet, because that really is the key tool for us when we're doing our review. When you give us that spreadsheet, make sure it is unlocked. It's not, hard-coded in there. It's got the working mathematics in it, so that if we are doing an evaluation of your effort, maybe we want to do a partial selection, we want to try to pull out some of the tasks, we want to be able to maybe manipulate that spreadsheet so we kind of have an idea roughly what that's going to cost when we're trying to see if that'll fit within our budget. It also helps afterwards if you've been selected and we start doing the price reasonableness determination, then we may not agree with your rates, or we may not agree with the number of hours you put in for a particular task. We want to then go in again and manipulate that and come up with a counter proposal to you that is an apples to apples comparison to what you actually proposed. If you don't do that for us, it's very difficult for us to understand sometimes how you applied your indirects against your directs. And so that's what this spreadsheet is really critical for us understanding the relationships in your cost estimations. Along with that, of course, there's also 2 attachments. There is a level of effort summary by task spreadsheet that we want you to complete. That again shows us how you're going to be performing the tasks. In addition to that, there's a proposal summary quad chart. That's a PowerPoint presentation and a quad chart. And both of these are attached to the BAA. There's examples out there for you to fill out. Make sure to give those back to us in that format. Don't change it. Don't turn it into a PDF. In particular, of course, the quad chart, because we like to use some of that information when we're putting together our presentations, when we go to the scientific review official and we're trying to put forward which ones we think are selectable and not selectable. We sometimes use that information as part of the justification. So it helps if you keep it in that format for us so we can get to the SRO faster. Like I said, the BAA is going to describe everything you need to fill out. It's going to describe for your technical volume the issues we want you to address and how, in what order we want you to address those. Make sure you follow that. It helps us when we're doing our read-throughs and trying to go through all the proposals. If everyone puts it sort of in the same format, that way we can then quickly, as we're reading through it, we don't have to kind of keep changing our brain around different formats. So follow the format that we ask you to put in there. Again, like I said, if something doesn't apply in Appendix A, just make sure you just mark it as none or not applicable so we know you saw it, and give us that working spreadsheet as part of your submission. So in your tech volume, you're going to be writing your own statement of work. That's what's unique about a broad agency announcement versus an RFP. We don't have a standard set of specs for everyone to propose against. So instead, we've got a problem. You're giving us the solution. You've got a unique statement of work you're going to put together. So part of when you're putting that together, there's some things we want you to consider, take into consideration as you're putting it together. As you're writing this, we typically like to, after you've been selected, cut that part out of your technical volume and make it an attachment to your contract. So when you're writing it, write it as if it is that attachment. Don't use proposal language like we propose to do this, we intend to do that. Instead, you want to tell us, I will do this. When you're laying it out, you want to break out the tasks between the different phases of the program. You also want to identify what milestones you have in the program. You want to identify what deliverables you have and where those are going to be delivered within this statement of work. So basically, your technical volume is going to describe how you're solving the problem. The statement of work is then going to show us how you're going to execute that solution. So make sure you tie that together when you're putting this out there, and make sure we understand how the tasks are being performed, who's performing it. Is it you who's performing a task, or is it being divided between you and a subcontractor? Is a subcontractor doing it? Let us know, so it helps us trace who's doing the work, and it helps us trace back to the cost volume so we can understand, do you have the right assets, the right number of people, right hours to perform those tasks in your statement of work. Don't put anything that's proprietary in there. This says mark all classified information. Well, that's from a different slide deck from probably a BAA that had a classified effort. There's nothing classified to it. but make sure you don't put anything classified in your statement of work, and make sure you don't put anything proprietary in there, because like I said, we try to cut that out and make that an attachment to your contract. It could be foiable at that point. We don't want anything that's proprietary released. So a few other prep tips, and I don't have it in this slide, but I'll go through it and I'll mention one other thing. When you're putting together the tasks and who's doing what, make sure that your PI in particular has a substantial time commitment, or someone in charge has a substantial time commitment. A number of times when I sit in on the feedback sessions, one of the areas that a lot of people will be dinged as a weakness in their proposal was they identified a really strong PI, but that PI is barely there. And there wasn't anyone else who we felt was the person in charge that we could reach out to. And so the concerns were, what happens if something's going wrong and this PI is not there? Who's running the ship at that point? We want to see some co-PI or somebody else there that you can identify who's going to have a more substantial time commitment. We realize that really good PIs are stretched thin, but what is the mitigation plan so that somebody's there that we can reach out to and find out if something's going wrong, or if we think that the research isn't going in the right direction, that we can have this revectored and have this project running. We don't want to wait and find out 4 years from now that it never worked and the PI wasn't there to fix it. So that's something to take into consideration when you're putting together your proposals. Another area, of course, we identify as risk. In your proposal, there is sections where we ask you to talk about risk, so make sure you do that. These are hard projects, we recognize that. So we want to make sure you guys recognize that there are risks involved, and we want to see, well, what happens and what is your mitigation strategy when those risks occur. So you need to discuss, what are the metrics that you've internally put into the project? How are you going to measure and find out if you are going down the right path? If path A is not going to work, what is plan B? Where's the next direction you're going to go? How are you going to measure that within your project? So we feel that you recognize that there are risks, but you also have a plan to mitigate or deal with those risks throughout the project. Another area, of course, people always complain to us about is page limits. How am I could have told you more if you'd given me more pages, and I could have really gotten my idea across. Well, we don't have that much time. We're trying to get these things put on contract very quickly. So we need you to limit and be concise with how you're going to solve this problem. So what's important to remember is depth is better than breadth. So if you think, okay, my solution can solve problem A, but it also can do problem B, problem C, problem D, that's great, but we really want you to focus in on A. Make sure to focus in on A and how you're going to solve A. You can, if you're selected and you get awarded, then at the PI meeting, you can then talk about all these other potential solutions that may help the government as well. But right now, if you waste a lot of time telling us about these other things, but don't really convince us you're going to solve problem A, then you're probably not going to be selected. So get selected, then you can tell us about all these other great things it could do. So that's what's important when you're doing this. The other thing I don't have in here is, if you're not familiar with the Heidelmeier questions, learn it and live it, because that's what DARPA lives by. And the PM, when he's going forward and he's pitching his program, he has to answer all those questions. So when he's looking at your solutions, he wants to see if that also answers the questions. If you're not familiar with them, just go Google it. It's out there. But make sure when you're writing it, and I think we even have in the BAA, hey, think about these things, address this in your proposal. So make sure you do that as you're doing the write-up. So intellectual property rights, this is always a fun topic for everybody. So I gotta take a drink. We can't tell you how to propose or what sort of intellectual property rights that you're going to assert. We can't restrict you from using any possible solution that's out there. What we do remind you is DARPA is taking nothing, and then we're trying to prove it works. And then from there, we then transition it to other people to then harden it, make it into a program of record, et cetera. That's what would be a success. If there are intellectual property restrictions within the process there, or things that make it hard for us to transition it to another partner without them having to go out and spend millions on licenses, that can be seen as a problem. That can be seen as a weakness in your solution. So bear that in mind. If you have a proprietary solution to this problem, think about how are we going to transition it, and how are you going to then mitigate that risk of us saying, well, that's too expensive, we can't transition this even if it's a success. So when you're writing up your proposal in Appendix A, there's a section for you to identify if you're asserting any IP rights. So we've got two tables in there. One is for non-commercial and one is for commercial. If it's a commercial item, that means there's an existing license out there. Identify what that license is and tell us how we can either pull up that license if there's a link out there, if it's say it's an open source license out there that there's a link to it. Let us know what that is so we can go look at those licenses and see if there is, making sure there's nothing in that license that would prohibit us or cause us a problem from our transition path. But if you're providing us a proprietary solution or something that you've developed with your IRAD that is not a commercial item, there is no existing license out there, then what happens is we fall under the DFARS at that point, and you can provide it to us in several different licensing types. You could give us unlimited rights, in which case you don't even have to annotate anything in your proposal. That we just always assume if you didn't assert something less than unlimited, then that's what we have. But if you're going to assert something less than unlimited, government purpose rights is probably like the minimum we love to have, because then we can still have some flexibility with that. There's also limited or restricted rights depending upon if it's technical data or software. It's all defined in the DFARS there, and those two are roughly the same thing. If you're giving us something less than unlimited, a couple things, of course. Make sure you identify why you're making that assertion. Is it something you developed with your own funding? If so, if it's an IRAD project, can you identify what was that specific IRAD code or number or account that you track that cost, the funding under? Make sure you identify exactly what it is you're asserting the IP towards. If it's software, give us the specific software version. And give us a name. Don't call it like a broad category of software, because that could mean anything. We want you to identify specifically what it is you're asserting the right to, how you're asserting that right, and what licensing you're going to provide us in your table that you provide us in the chart. If you have any questions about that, of course, go read the DFARS. It's very in-depth about that. What we also, though, want you to make sure that when you give us something less than unlimited, along with that justifying the basis of your assertion, call out what other mitigation strategies there are. If you're going to give us something with limited rights or restricted rights, is there a potential that you're going to give us a unique license that we can then use this beyond just this project? I mean, maybe you'll give us a unique license that allow us to give it to 10 people beyond here. Something that helps us figure out, well, can we transition this without it being too super expensive? Also, are there other alternatives? Your solution might be the cheapest, but in the long run, it might be cheaper for us to pay for you to develop something on our dime that's similar to this. So consider that, give us what those different trade-offs are, and let us make that decision in the end if we want to do the trade. But make sure to identify that in there. A couple other things to note. Typically, the proposals, after they come in, it takes us roughly 180 days to kind of cycle through to maybe 210 days. So if you're planning out when you think the program is going to start, that's usually a good gauge for you to use. I don't know if the BAA specifically called out when we expected it to occur, so use that as sort of your model. So when you're pricing it, you can kind of identify when the start time is from the proposal receipt, roughly 180 to 210 days from there. If you're subcontracting in any way, it's important to remember a few things. If you're not a small business, then you're going to, depending upon the dollar threshold, if your proposal is greater than $700K, you're going to have to submit a subcontracting plan as part of your proposal. You can put that in the cost volume. It's important. The DoD has a requirement that we identify if you have a small disadvantaged business goal of 5%. If you don't have that, which can occur very easily in R&D. We get it that there may not be someone who's a small disadvantaged business that does the unique research that you require. Identify why you weren't able to achieve that goal for small disadvantaged businesses, because it is something, if it doesn't occur, then we have to go through special steps to get the plan approved. It helps if we have your explanation identified in the plan already, so we can then justify and say, hey, they couldn't get 5% because, and then there's your rationale right there. Then when you're submitting your subcontractor proposals as part of your cost volume, it's important that you provide us with an actual proposal from your sub and not a ROM. We don't want an estimate of what you think their costs are. We want to see a firm proposal from them. We recognize that they will probably give you a non-proprietary, or what we call a sanitized proposal, and that's fine. We just want to make sure that there is a proposal. If you give us ROMs, we're going to consider that a weakness, and we may even throw your proposal out, because that leaves too much uncertainty. We don't want to budget something and find out when we get into negotiations your subcontractor costs twice as much as what you thought. So you need to give us their firm proposals to you as part of your cost proposal. Now, if you're selected, then we want to make sure that that subcontractor is ready to give us their, meaning, send it directly to the government, their unsanitized version. So make sure you work that out with these subcontractors, that if you're selected, they're going to have to give that to us immediately so we can go through and evaluate all their costs. And then if you're utilizing like a federally funded research development center, a university affiliated research center, government entity, some sort of foreign firm, there are some eligibility requirements that are laid out in the BAA for those unique performers. And you have to make sure, if you're using them as a sub, that they provide that information to you. In particular with the FFRDCs, UARCs, government entities, they have to justify and prove that they are not directly competing against industry, that they're not taking money away from industry by what they are, the services or techniques or whatever they're providing. So you have to have that as part of your proposal for us to validate and make sure that those subs are eligible to receive a proposal. A few other things to bear in mind. You got to indicate the minimum number of days that your proposal's valid. Yes, thank you. So make sure you indicate that in your proposal. I say if the BAA says like a minimum of 120, give us the 180, just so that it gives us enough time to get through the evaluation process and get it awarded. If anyone has a conflict of interest, DARPA has what we call CETA contractors here. They are people who work inside and support the government, but they are not government employees. But we have them under a lot of strict NDAs. If you happen to be one of those firms and you think, oh, I could also be a performer, you are allowed to submit a proposal, but you had better have a really good solution and a very good mitigation plan, because we will have to take a look. And if you can mitigate that conflict that exists, then there is a potential you could be awarded. But like I said, you had to have a very good solution, and we have to weigh the risks before we would actually consider that. If you think you have any other kind of conflict, make sure you identify it in your proposal so we can take a look. Make sure you submit the documents with those in those formats. Make sure you submit it in English. There is an associate contractor agreement requirement. Make sure you understand that. That is something you would have to sign prior to the kickoff meetings, so that it's a document that sort of talks about how everyone's going to share information within the program, what information you're going to be willing to share, what you're not willing to share, so that we can all make an interoperable system that it's going to work going out the gate. I don't think we're having classified proposals, so ignore that, and ignore your security class guide, since that's from another type of program, and make sure that, of course, your whole proposal is unclassified, not just your cost volume. So if you've never been through one of our processes before, how we do the evaluations and awards, it works out a little differently than a typical FAR 15 RFP. Since no one has a common statement of work or specs that they're proposing against, each proposal that comes in is evaluated on its individual merits compared to the evaluation criteria that are laid out in the BAA. We've got a group of experts. They'll look through the proposals individually. do a write-up of the strengths and weaknesses based on those evaluation criteria, and then they'll make a recommendation whether or not they think it's a selectable or non-selectable proposal. We can also do what we call partial selections. We may find part of your proposal is very good, part of it's very weak. So sometimes we do partial selections. Program manager gets all those write-ups, decides what can fit within his portfolio, goes before the scientific review official. The scientific review official makes the final determination. From there, once we have determined who is selected, who is not, we send out notifications to everyone. Part of that evaluation team may involve the CETAs at work here, or maybe outside subject matter experts. Those individuals, they don't have recommendations. They don't actually make the recommendations. That's always done by government employees. SMEs, though, would give everyone on that team who's evaluating it some sort of insight into something special, or whatever knowledge they have they may add to the argument. But ultimately, it's a bunch of government employees who put together their recommendations to the program manager, who then goes before the SRO. So the reason I'm pointing that out is just to make sure you understand that although we may have people who are not government employees looking at your proposal, they are under NDAs, and they're not allowed to reveal any of that information. And then, of course, in the end, the government reserves the right. We may select some proposals, none of the proposals. We may select your proposal, but we only like half of it, in which case we go back out to you and have you revise part of your proposal, your cost volumes, and your statement of work, and resubmit those to us. So it's the communication, the BAA is out there. Ray's open to talk to anybody. We do have abstracts that we are going to have you submit, and they're coming in roughly 2 weeks. It's not this Friday, but next Friday is the submission time frame, 12 o'clock Eastern time. Make sure you get those into us if you want to get feedback on whether or not your idea is in scope or out of scope. That's pretty much what Ray's going to provide you. If you're out of scope, he's going to give you some feedback why it's not in scope. But other than that, that's the best opportunity for you to find out if your idea is within pursuing under this proposal or under this BAA. Ignore anything about classified FAQs. This is not the right set of slides. So that's the communications, open communication at this point. Once the BAA closes, then there is a tighter communication, and usually the only one who communicates with you would be me or another contracting officer here at DARPA, asking you to clarify maybe something of your proposal that's not quite clear. Or if maybe you forgot to fill out part of your Appendix A, we don't know if you have animal usage, we may come back and ask you to clarify that for us. Other than that, then there is no other communication. Nobody else will talk to you as we go through the evaluation process. Once we complete the selection, we send you a notification one way or the other. If you are not selected, then we offer you the opportunity to establish what we call a feedback session with Ray, where he will talk to you on the phone for 10 to 15 minutes, go through just your proposal, and discuss all the strengths and weaknesses that he found, and give you feedback that'll help you maybe fill out and submit a better proposal next time. He's not going to talk about any of the programmatics. He's not going to talk about how many proposals he received, or who he selected, or how many he selected under a particular TA. All that information would be considered source selection sensitive, so he can't discuss it. What will happen is once the people who are selected, their awards are made, then usually we post something on FedBizOps every time we make one of those contract awards. And of course, if you are selected, depending upon whether it's a full or partial selection, if it's a partial, we come back and say, hey, congratulations, we want you to propose again for these particular tasks or propose everything but this task. And all we ask you to do is then give us a revised cost volume and a revised statement of work or any other particular piece of your proposal that maybe had changed. If, say, your IP assertion list is different now, we ask you to resubmit that to us. Otherwise, if you're fully selected, then we give you a letter, and the next person who reaches out to you would be the contracting officer to negotiate an award. So the good news is we're almost done. Takeaway, make sure you submit your proposals to us on time. It's July 9th at 12 o'clock Eastern. So you're going to be submitting only through the BAT tool. If you don't have an account set up, or if it's been a long time since you've been in it, go now and set up your account. It doesn't cost you anything, but it is a 2-step process. So you don't want to wait until the last day, the last minute to try to get your account up and running. If your password has expired, don't wait till 5 minutes before 12 o'clock and realize you got to reset your password. Don't log in the night before and leave it open and then go at 5 minutes before and expect it to still be open. You know, the system will log you out at that point. The reason I'm saying this is because these are the things that have actually happened and that drive me crazy, because people then call me up and complain that our system doesn't work. But in fact, it does work, and you are the ones who are having a user error. Make sure, again, you don't wait for the last minute, because we can see when you logged in. Don't try to blame the internet if you don't get it to us on time. Remember, if you're sending it the last minute, 11:59, it may not get to us till 12 and 1 second, and the system will shut you out at exactly 12 o'clock. So there is no pity or remorse in this system. It will not let you through. So if you are trying to submit it and it's after 12 and you're getting an error message, that's because the system is shut down. You're no longer eligible to submit a proposal against it. So get it in before then. I've said this before, your chances of getting selected exponentially increase if you actually get us a proposal versus those who don't get us a proposal. Again, read and understand the BAA, understand how all the different TAs work. You may only be proposing against one TA, but there is, connections and interoperability between them, so we want to make sure you fit within the whole project. So make sure your piece fits when you're doing your write-ups. Be familiar with the IP terms. Make sure you assert any IP restrictions that you think are necessary. Otherwise, we're going to assume everything is unlimited use if you don't. Make sure to give us the working spreadsheet. The unprotected spreadsheet is part of your cost volume. Ultimately, remember, too, that only the contracting officer has the right to obligate the government and bind the government. So if there's any time after you've been selected in negotiations, if there's any technical discussions that may change parts of your cost proposal, make sure your contracting guys pass that information back to the government so that you guys are negotiating, everyone's negotiating the final product that is going to meet both the statement of work and the budget values that we put on the contract. We don't want to find out later on you forgot to add some costs in and now you can't achieve what you said you were going to do. So with that, that's the completion of my slides. If you have any questions, make sure to write them down and we'll collect those and answer those in a little bit.
Next, we'll have a half hour of 2-minute timing talks. And I'll butcher people's names. Please forgive me. So I'll tell you who's up first and who's up next so they're ready. Then when we switch, I'll tell you who the person after that is. Nanan Medjevic from University of Southern California will start. After that, we'll have Greg Wilds from DornaWorks. And with that, you have 2 minutes.
Okay, thank you. So I'm Nenad Medvedovic. I go by Nino. I come from USC. I am here on behalf of 2 other colleagues who are also working in the area of software engineering as I am. One of them is Chao Wang. The other one is William G.J. Halfond. Our research spans different sub-areas of software engineering. Chao focuses on formal verification. GJ works in the area of software analysis and testing, and I work in the area of software architecture, including modeling and analysis of large code bases. We work with various types of things that are relevant to this program, most likely to task area 1, things that involve everything from modeling invariants, protocols of interaction between components, scaling things from lower level models to higher level models, various types of visualization, which could present information that is automatically derived to a human assessor who might be interested in them. And one of the things that we have been doing, and we have developed a rather powerful tool set over the last 5 or 6 years, is basically using software systems as series of big data repositories that we can siphon information from. So one of the things that we have shown is that, for example, by looking at a set of software systems, we can actually predict what is likely to happen to a given system that we haven't seen before based on the kinds of architectural characteristics that system might have. Anyway, we're looking to potentially team up, and with that, I'll stop.
Next is Greg Wild from DornaWorks. After that will be Matt Gallagher from CAS Software.
Hello, Greg Wilds from DornaWorks. We're an innovative small business based in Grand Rapids, Michigan. We focus on embedded platform expertise at the software-hardware interface. We're a performer on multiple CBERs with DARPA around SEL4, embedded security, and high assurance systems. Our focus is going to be around supporting team members on task 1 around the 4 types of evidence outlined there of test, simulation, emulation, analytical, and software quality assurance. Along those 4 areas, the test piece, we have expertise in Jenkins automated tests, legacy and new software as outlined in the solicitation, including ARCOS out there, as well as SEL4 and formally proven software. And then multiple platforms. DornaWorks has done work in embedded virtualization along x86, ARM, and RISC-V platforms. Around 2 for simulation emulation, representative or virtualized hardware platforms. Formal methods, we work with a number of organizations that do formal analysis and collaborate effectively with them. And then around SQA, our engineering team has experience with DO-178 and DO-254 across aerospace, defense, medical, automotive, and interesting technologies like multi-core, which is utilized in some areas and not so much in aerospace quite yet, as well as VHDL, so FPGA world, as well as embedded software. I'll leave it at that. Thank you.
Okay, Matt Gallagher's next. He'll be followed by Marcos Ward from Northrop.
All right, my name is Matt Gallagher. I'm the Director of DoD Programs for CAS Software. We are an enterprise commercial software company, primarily in the space of code visualization and understanding. Primarily, our customers use us to do system-level analysis across codes, not just individual modules, to understand things like complexity of the software, software health, software composition. We work on a number of DoD programs. I see us primarily also in task 1 to get the understanding of the code, understand the dependencies throughout the whole system, and ultimately to assess risk, understand open source risk, et cetera. So that's primarily where our customers use us today. Looking forward to working on the program.
Next is Marcos Ward.
I'm Marcos Ward again. I'm from Northrop Grumman, the aerospace sector. Colleague from Mission Systems is here also. Kind of some background, the separate sectors. So we're looking at the AS sector does pretty much aerospace, everything from the ground to the air. So we're looking primarily at TA4, specifically for aerospace sector, and kind of can provide the platform. So we're looking for teammates there. Also, TA1 and 3, I believe, also for Mission Systems. So we do have some algorithms. We are currently participating in several kind of DARPA and other CRAD efforts that kind of relate to assurance. So we do have some algorithms. We do have some experts in those areas. So if any of you guys are interested in teaming with us, come see us. Thanks.
After that, we have Alexei Nagin from HRL.
Good morning. My name is Alexei Nogin. I'm from HRL Laboratories, formerly Hughes Research Labs. We're about 400 plus people in Malibu, California. And I lead their Center for Secure and Resilient Systems. In our, so we have a number of researchers in formal methods. We led the ground team integration for the HACMS program, putting together the formal methods technologies to develop high assurance software for ground vehicles. We currently perform on DARPA Assurant Autonomy, which is a program that combines machine learning and formal methods. So we also have experts in big data, machine learning, and in this program we're interested in TAs 1 and 3, and we're looking for partners. Thank you.
Next up is Frank Vertrick from EdgeCase Research. He'll be followed by Gustavo.
Hi, good morning. I'm Frank Fratrick from EdgeCase Research. We're a safety company. We work with military and commercial companies to build safety cases for their systems, lots of robotics and autonomy. We have tools that we do mostly with stress testing, so off nominal, not happy path, right? Trying to find anomalies via robustness testing around interfaces and autonomy, and specifically in perception, trying to inject noise and find problems with perception algorithms. For me personally, I spent the past 15 years before joining EdgeCase as an Army test and evaluation civilian, and I've been a part of that software certification body on the government side. So understand the challenges there and the value of ARCOS. Mostly focused on TA1, I think, looking for complementary partners. Thanks.
Gustavo's next, followed by Yangfang Kai from Drexel.
Thank you. So again, I'm from Siemens Corporate Technology. That's the research arm of Siemens. So we are a little bit more than 2,000 researchers spread out across the globe, and we have all sorts of topics. Actually, for this program, I would like to mention we mostly have expertise in like software engineering, runtime systems, as well as engineering systems for safety critical systems. We have teams for IoT, data analytics. We have a cybersecurity team, and we also have teams working on autonomous systems for robotics, but also all the other aspects, even electrical networks. So on that note, as you saw the presentation earlier, you've seen the focus of the work that we've been doing in this area. For teaming, we see interest in looking for partners which have particularly strong capabilities on code analysis and extraction of information, say from source code and binaries. That would be an interesting partner for us. Also, formal methods, especially applied to safety critical software. So partners with strengths in these areas we would like to talk to. And finally, and especially because this is not a topic that we have addressed in our seedling, but of course it's a central topic in the ARCOS program, is software certification. So if you have strong skills in software certification, we definitely like to talk to you and to look at possibilities for teaming. Okay, thank you.
Yangfang Kai from Drexel, then Carol Schmitz from Ohio State.
Good morning. My name is Yuanfang Cai. I'm associate professor from Drexel University, and in the past 10 years, I've been working on research on software modularity, and we found it's the foundation, for many other quality attributes like scalability and security and vulnerability, etc. Right? And so recently, we proposed a new metrics, modularity metrics. We call that decoupling level, and which is based on the real options theory proposed in Harvard Business School. So using this metrics, then people can fairly compare the modularity level of different projects so that we are forming an industrial benchmark so that the manager can see, oh, my software is only ranking 20 percentile comparing to other projects in industry. So we have been applying this to multiple industrial companies. It's very effective so far. Another research advantage related to this program is that we found for files to be very error prone and vulnerable and has many problems, And more likely, these files are not independent from each other. There must be an underlying architectural connection that is propagating these errors through multiple files and making the overall system very difficult to evolve. And so our job is to identify the architectural problem that is propagating these errors and vulnerabilities and quantify their effects. And all these advances has been incorporated in our tool called Titan, which I believe has been licensed by Defense, and we hope Department of Defense, and we are hoping to collaborate with companies and DAPAN to see this tool being used by more and more partners. Thank you.
Carol Schmitz from Ohio State, then Dino Schmalovic from ENSCO.
My name is Carol Smith. I'm the director of the Reliability and Risk Laboratory at Ohio State in mechanical and aerospace engineering. So my research has been on high assurance software systems, and we've been funded in the past by the US NRC, Nuclear Regulatory Commission, NASA, the Air Force, and DOE. So some of our research has been on automated software testing from specifications, in particular acceleration of techniques which use very probing approaches such as software mutation. We've worked on development of model-based approaches that look at robustness issues. And in the past, I've worked for quite some time for NRC on linking software engineering measures that are obtained in the different phases of the life cycle to software reliability estimations. So I think that talks directly to the types of issues we have here. We've applied this on some reactor protection systems, and we've gone further in looking into extending this for other dependability metrics, just such as availability, maintainability, and so forth. So we've developed tools associated to these different approaches. Those tools are available. We work in collaboration with different universities, so I think we would bring those to the table as well, such as University of Tennessee, Oregon State, and Virginia Commonwealth University. And we work with small businesses that are specialized in certification, especially for the Department of Energy and the US NRC. So of course we have also access to the resources of Ohio State University, such as our Big Data Transformational Center, which has some 70 faculty. Thank you.
Thank you. Dino Schmalovic, followed by Ensuk Kang from CMU.
Hello, everybody. My name is Dino Smilovic. I'm a Director of Business Development for ENSCO Avionics, located in Endicott, New York. It's a part of it's a division of ENSCO. We have about 35 years of experience of software development and certification for DO 178, DO 254 standards, and some other standards. We support all stages of development cycle with emphasis on testing and verification. We utilize our own developed technology that we call universal test environment technology that's scalable, software configurable, highly automated, and supports development, integration, verification testing, simulation, SIL and HIL, and software process analysis. We have in-house facilities that have contain secure test labs, remote access, secure network and communication protocols, and obviously implementing configuration management and software quality assurance. Currently, we're also developing, looking into exploring machine learning to help accelerate verification activities. And I'm here with my colleague Arnaud Gain. He's our software engineering manager, and obviously will be available later to talk to anyone who's interested in teaming with us. We are looking at probably TA 1, 3, and 4 areas. Thank you so much.
After Ensuk Kang will be Nico Pollack.
Good morning. My name is Ensuk Kang. I'm an assistant professor of computer science at CMU. And here I'm representing the software engineering faculty at CMU. So our team consists of David Garland, who's an expert in software architecture, Jonathan Aldrich, who works on programming languages and type systems, Claire Legous, who works on program repairs and program analysis, and Christian Kestner, who works on software product lines and testing, and I myself work on formal method and safety and assurance cases. So we're looking into TA1 and TA3, and if you're interested, I would love to talk to you afterwards. Thank you.
Nico Pollack apparently is not speaking, so we'll end with you for the morning.
Hello, good morning. I'm Alessandro Pinto. I'm a fellow with the United Technologies Research Center. United Technologies is a large aerospace company. We have two subsidiaries, Collins Aerospace and Pratt & Whitney. So we're very familiar with the problems that have been outlined this morning by Ray. And in this particular case, for ARCOS, we are interested in Technical Area 3. And in particular, we are familiar and we have expertise in the area of synthesis, starting from hierarchical representation of compositional descriptions in general, contracts. And also we have a strong background in uncertainty quantification, especially in the case of rare events that we believe is relevant to this case. We are looking into partnerships, for example, for expressing results of the analysis in Technical Area 3 for human understanding. And also, we are very interested in talking in general to whoever is interested in Technical Area 2 to make sure that there is an interface that could be leveraged during the program execution.
So we have 38 questions. Some of them are duplicates. I'll read the question, then I'll read the answer. For the legacy software thrust of TA1, can we assume that the source code is available, or would solutions that handle binary-only legacy software be preferable? The answer is solutions for either are attractive. The ability to process binaries is important. And I'll point out what Dr. Seal said this morning, that they don't always have source code. Question 2. For legacy software, would artifacts produced by past legacy certification efforts be among the evidence that may need to be handled by the appropriate TAs? The answer is yes. Question 3. The BAA focuses entirely on establishing that risk is acceptable. What should happen that it is not? What are the TA3 responsibilities for cases when evidence does not support an assurance case, or at least not to any meaningful degree or confidence? What are the TA3 and TA1 responsibilities when given software that perhaps ought to be rejected rather than certified? Does the N out of 6 evaluators agree metric apply only to successful creation of an assurance case? And I'll go back to the mission statement for the program. The goal of the program is to produce assurance cases that are a meaningful representation of the confidence in those assurance cases. Whether the certified software based upon assurance cases is beyond the scope of the program, not all software is worthy of certification. Question 4. On page 7 of the BAA, the diagram and color coding for human and automated, is that correct? I would have imagined more human involvement would be needed in the legacy software. And the response to that is automated solutions are preferred. Question 5. Can you give an example of certification criteria? DO 178, question mark. So the sorts of certification criteria we're interested in include DoD airworthiness certification criteria, and that is a document you can Google. DoD system safety, also a document that can be Googled. And common criteria, which I mentioned it in my slides, also is certification criteria of interest. Question 6, is ARCOS focused on baseline certification? The response is ARCOS is focused on developing techniques to provide compositional automated evaluation of software. Question 7, is recertification technologies in scope? The response to that is, ARCOS is focused on developing techniques to provide compositional automated evaluation of software. Question 8, are TA3 proposals that address both goals preferred? The answer is yes. Question 9, can you expand on what is meant by assurance-driven development? It appears only once in the BAA. So by assurance-driven development, the development of the assurance case precedes and informs and influences the development of software from design all the way through implementation and test. Question 10, who drives the process? I wasn't sure what exactly they were driving at, but hopefully I've answered it. The goal of the program is to automate the evaluation of software assurance evidence to enable certifiers to determine rapidly that system risk is acceptable. Question 11, where does the end user initiate the certification process? Platform owners will initiate certification efforts when necessary. Question 12, what is SQA intended to cover? Mainly process. So yes, it's intended to cover process. You can think of the objectives in DO 178. It's the software assurance practices that were used in the development of software. Are you encouraging virtual teams that cross TA boundaries? It is up to the proposers to determine how to bid. Question 14. Is legacy software for TA1 considered to be black box or white box? Source code available or just binary? Solutions for either are attractive. The ability to process binaries is important. Question 15. Does the prime contractor need to have a person with a secret clearance, or can this person be from the sub? One team member must be cleared. It doesn't have to be the prime. Is the program funding 6.1 or 6.2? The answer is 6.2. Will industry participants be allowed to conduct fundamental research? For 6.2 funded efforts, industry or any non-university work is considered non-fundamental. Question 18, just to confirm, abstracts from prospective proposers are due to you on May 24th, correct? Would we send them to this email address? Yes, they're due May 24th at noon, Eastern Time. Directions for submission are in the BAA. Question 19, will different business sectors in the same company be considered separate entities? For example, if one sector is awarded TA4, would that preclude another sector from being awarded TA1 through 3? The response is proposer entities are defined by cage codes. Question 20, how big will each award in TA1 and 3 in terms of funding amount? The response is it depends on the quality of the proposal. There's no predetermined value. It will be based on the number and value proposals received. Question 21. How are deltas in government organization assurance expectations desired to be addressed? Will an agreed upon set of assurance criteria be provided? For example, even among the DoD services, there can be differences in software safety, level of rigor, task requirements. The response is the level of rigor will depend upon what's bid by the TA4 performer, but a high level of rigor should be anticipated. Question 22. Is there a desired weighting of safety versus security assurance? Are both required? For example, could a strong proposal address only safety assurance? So we're considering assurances at a more abstract level. And I mentioned in the earlier talk that we want to take a step back and be able to demonstrate that we've built the right software. You need to be able to demonstrate assurance claims that are true we need to be able to demonstrate that assurance claims are true regardless if they're safety or security. Question 23. Can you elaborate on the certification criteria to be used in the program? Are there going to be ambiguous certification requirements like the complexity requirement I mentioned in common criteria? There will be no ambiguous criteria. They'll be pulled from the sources I've mentioned. Criteria will be pulled from DoD airworthiness, system safety, and various DoD security criteria. How much is the overall budget for the ARCOS program? We're anticipating contracting out $68 million approximately. Question 25. Can you clarify the requirements box feeding TA1, I'm assuming in the diagram in the BAA? Is the intent that TA1 captured the derivation of evidence from traditional artifacts, including docs and design models? So the requirements box was intended to be whatever you needed to complete the effort, including software assurance evidence, software requirements, and software certification criteria. Question 26. What defines conflict of interest between TA1 through 3 and TA4? Would separate business units under the same umbrella company fall into this category? Determinations will be made based upon cage codes. Question 27. Will abstracts that do not have the cost and teaming info still be evaluated and feedback provided? The answer is feedback can only be provided on information submitted. It may be difficult to determine feedback based upon incomplete information. Question 28. Are there recommended or preferred sizes for TA1 and TA3 teams in terms of PIs and projects in terms of dollars? The answer is no. Question 29. Are there particular implementations of interest to focus on for evidence generation? For example, C, Java versus Rust, Scala. The response is the implementations of interest will be those implementations that are of interest to the DoD. Question 30. Can you give us some clarification on the desired scale of modules in the TA4 assessments? Is it what a customer might consider a module, for example, the flight planning software package, or is what a software architect might consider a module, for example, the flight planning software's back-end reasoning engine? The response is something a software architect might consider a module. Question 31. For the assessment platform, is there a preference or for cyber-physical platforms or platforms that are purely software? If so, which is preferred? So the preference is platforms that have a rich set of certification criteria, meaning that they pull from system safety and security or airworthiness and security, but one that only has certification criteria in a narrow domain is not of interest. Can you clarify on the key performance indicators for TA2, or is it just the number of nodes we can handle? So what is of interest in TA2 is the scalability, so the number of nodes, how much data you can support, and can you support evidence from the 4 classes of evidence that have been articulated. Question 33. TA2 appears to be the system integrator creating APIs and mediating between TAs 1 and 3. And in parentheses, yes, and my response to that is true. Can the same performer bid TAs 2 and 4? You can propose any TAs you like, and can you perform on both? You'll not be selected in both roles. Question 34, assessments. Who runs the tools? Do the performers run their own tools, or does TA4 and the SMEs run the tools? The response is the performers will run the tools in conjunction with TA4. The SMEs will only look at the outputs of the tools. Question 35, where is the data, the input, in parentheses data, for TA1 and TA2 coming from? The answer is they're coming from TA4. They're providing the testbed inputs. Question 36. The TA1 split between legacy and new software seems a bit unrealistic given every system is a mixture of totally new, re-engineered, and reusable components. Is it appropriate to merge to some extent the TA1 proposal to cover this spectrum rather than making a strong split? The response is proposals that cover both are encouraged. Question 37. Can I elaborate and provide examples of what is meant by curated nodes? Is this lines of code? No, it's not lines of code. So curated nodes, I'm anticipating that TA2 performer will build evidence graphs very similar to the evidence graphs that were shown in the seedling results. And the number of nodes in that graph are what we're interested in as far as scalability. Question 38, and final question. Will a list of potential teaming partners be distributed? The answer is no, but we're trying to, we don't want to be the middleman and have somebody left out of a list or not receive a list and feel like they've been treated unfairly, so we're not getting into that business. We're providing the 2-minute sessions and out in the reception area, a place where you can leave your card if you want a team in a particular area and others can pick up that information at the end of the day. So that's the end of the questions. And these will be posted, and I think I said FBO earlier, and that's incorrect. They'll be posted on the DARPA ARCOS website, along with my slides and other such information. Yeah, so there will be an FAQ posted there, and if there are additional questions that come through appropriate channels, they'll also be added to the FAQ. With that, the remainder of the day, we'll have more 2-minute sessions. We have 4 more people signed up, and if anybody else wants to do it, we'll ask for hands at the end. Then this room will be open until 3:30 if you want to network and have teaming discussions with your potential teammates. So the next 2-minute introduction will be Benjamin Lee from Duke University, and he'll be followed by Thomas Williams.
Right, good afternoon. My name is Benjamin Lee from Duke, and our team has expertise in applied statistical machine learning for software systems and its interface to hardware systems. We've been developing a suite of statistical models and frameworks that help us generate robust predictions. We use an ensemble of methods. There's no particular method that works best for all scenarios, and we have a pipeline of methods that we reconcile with each other to make sure that the outputs are consistent. We have methods that can assess confidence in the outputs. So this often relies on an underlying understanding of the statistics. So we like Bayesian methods. And third, we come up with interpretable outputs from our machine learning models. We link natural language processing methods to those, on top of those models, so that the user can look at these outputs and get some domain-specific insight. We've demonstrated these frameworks on 2 large data sets, one in collaboration with Google. We've looked at a 140 gigabyte data set on their system trace of a production data center, and we've been able to do anomaly detection and workload classification. We've produced domain-specific interpretable insights, and we've reconciled them with previously published diagnoses of system behavior and software behavior. Second, we've been collaborating with Facebook on a large data set. We've been doing trace analysis and call graph analysis. Again, this is a very large data set, and we've demonstrated scalability on both data sets. Our machine learning methods, our analytics, can complete within tens of minutes on hundreds of gigabytes of data, because we have scalability and we have parallel implementations of our methods. For ARCOS, we're particularly interested in TA3 because we're interested in doing assurance generation. We think we have unique capabilities for providing domain-specific and interpretable results that can be analyzed by the evaluators. That's what we've done for some of these other industrial data sets, and we're looking forward to engaging with teams for these needs. Thank you very much.
Thomas Williams is next, followed by Chris Horn.
I'll try and keep it quick. My name's Tom Williams. I'm with CS Communication and Systems, office out of East Hartford. I'm here with my chief engineer, Matt Tack. And really our specialty is in safety critical embedded systems. We've got high-end expertise in embedded software development, V&V, formal methods, so everything related to DO 178, SQA. And really our focus right now has been on defining traceability for testing at the low level on system level tests so that we can maximize and streamline the generation of artifacts. So our principal interest is probably TA1 and TA3 sections. And then if anybody is leveraging automotive type use, ISO 26262 also exists in our wheelhouse. So as we look towards kind of the ground vehicle market, that might be a play and factor. But looking to partner with people in this effort. Thanks, guys.
Chris Horn, followed by James Pendergrass.
Hey, good afternoon. I'm Chris Horn with Secure Decisions. So we're a small business on Long Island, about 80 people. We do cybersecurity research and development. We're performers on DARPA and DHS contracts presently. We have experience as both prime and sub, but we're looking for a sub role, probably on TA1 or TA2. We've got experience in crafting compelling stories and presenting information to users. So visualization of application security and generally cybersecurity data. We do a lot of human factors work, again, on dashboards, application security metrics, user stories, things like that. We also have a strong systems engineering capability, so we can provide engineering support. We build, for example, on DARPA, we've generated large volumes of static analysis results. And we also have a spin-off company that we've transitioned some of our DHS research into a separate company. And that product called CodeDX correlates the results of multiple static analysis tools. So we support over 40 different static analysis tools. And that product also has an orchestration capability to run large amounts of static analysis against various software, which is not a straightforward task. We also have an embedded systems engineering capability, but that's probably not as relevant, but I'll just mention it in case somebody thinks of something. So we can help with generating data. We can help with systems engineering in general. We've got a lot of experience also with test harnesses and test beds, providing engineering support for that. Thank you.
James Pendergrass, he's the last one signed up, and after he is done, we'll take volunteers.
Hi, I'm James Pendergrass, or I go by Aaron usually, but I'm from the Johns Hopkins University Applied Physics Laboratory. Specifically, I work in the Software Assurance Research and Applications Lab at the JHU APL. My group is focused on software assurance and working software assurance and analytic tools into the development process and certification processes, but the laboratory writ large participates in development, engineering, certification processes on all sides. So we have efforts that are developing software that will be fielded in various platforms, as well as working to certify other teams' software as a trusted agent of the government, and on occasion sitting on boards for defining those certification criteria. So we've seen this problem from all sides and really appreciate the goals that Ray has laid out in this program. We are particularly interested in working on the TA2 or 3 roles. We see a great opportunity to bring some of our knowledge representation capabilities to TA2, or likely to bring a combination of formal methods, adversarial assessment, and human factors to TA3 to assess the capabilities of the argument generation tools. So we think that those are all very important ways to attack that problem of building a strong assurance case, and are very interested in talking to anyone who's interested in teaming with us.
Doug Stewart from Boeing.
Good afternoon. I'm Douglas Stewart from Boeing Research and Technology. As you may imagine, one of the things that we're interested in is TA4 for the platform, but we're also potentially interested in supporting the other TAs. In particular, we have some experience and capabilities in the area of binary code analysis, natural language processing, and then we have, as you might imagine, a rich understanding of the military safety and security certification processes that we could bring to the table if somebody's looking for that as part of their team. And we'll be around to talk. Thanks.
Another volunteer.
So I'm Ted Bapty from Vanderbilt University. We do a range of model-based tools, multi-domain modeling, composition for various uses for cyber physical systems and code generation, things like that. We're also part of the Assured Autonomy, where we're looking at learning-enabled, sharing these learning-enabled component systems. So we do a tool set for that. We also have the Institute for Software Integrated System, which I'm part of, ISIS. Is very large, and we have several people doing code analysis and different safety analysis techniques as well. So we're interested in TA1, TA3 primarily. TA2 we could do as well, probably in a subcontractor kind of role. Thanks.
Last call at open mic night. All right, that will conclude the structured portion of the Proposers Day. Again, this room will be open until 3:30. Feel free to network and chat with your peers.